Now we're going to talk about compound interest. This is kind of cool. So here's the formula for compound interest. You've probably seen it before. Um, so the A is the amount of present after 10 years. So however amount money you got after investing for T years. T is called the principal, which is your initial amount invested or initial amount borrowed. R is going to be your interest rate, your annual interest rate, and you have to change it to a decimal. T is the time in years, and N is the number of times compounded per year. So let's talk about this compounding because you've probably seen this formula before, but I don't know if you've seen like what it actually means. So let's talk about how compound interest really works. What does it mean? So we're going to start with, let's just consider that we're going to invest $100 and we're going to put it in a savings account that earns 12% interest each year. By the way, you're never going to find a savings account these days that earns 12% interest each year. Although savings accounts are paying fairly decently right now, but 12%, we're just using that number because it's going to be easy for examples. Um, we're gonna do that, and I'm just gonna add a parenthesis here. Um, and okay, so let's look at the interest if we were gonna compound annually. So that means that we're getting paid our interest one time each year. So what does that mean? Well, it's very simple. So initially, when no time has passed, we have $100. After 1 year, we have our $100 plus 12% of what was in our account, $100. So that's going to be $112. After the second year, we're starting that year with $112. So we'll add to that 12% of 112. So we earned a little bit more interest than we earned the first year. That's the compounding part because we're earning interest on our interest. Um, and it works out to be this. So you can see we've earned a little bit more than $12 the second year. And then after year three, we have this much to start with in our account. We earn 12% of that, and we get this, and so on and so on. So that's compounded annually. But now, what would happen if we did the same thing? We're going to start with $100. We're going to earn 12% annually, but it's going to be compounded quarterly. What does that mean? You're earning 12% interest annually, but it gets compounded quarterly. Here's what it means. So basically, what you do is you take the interest rate, because we're getting it's compounded quarterly, you're going to take your interest rate and divide by 4. So in this case, 12% divided by 4 is 3%. So we're going to earn 3% every fourth of a year. So in the end, we're earning 12%. But because of the compounding, you're going to see that we're going to get a little bit more than 12%. So here's how it works. So again, at year zero, we have $100. We're starting with that. Now, after a quarter of a year, we're going to have $100 plus 3% of that $100. So we're going to have $103. Now, after another quarter, when we're at half a year, we're going to have $103. And this time we earn 3% on the $103, not just on the 100. So we get this. And then after three-fourths of a year, we earn another 3%. And then after another quarter, we earn another 3%. And here we are. And if you remember from this table, after 1 year, when it was compounded annually, we had $112. But with the same interest rate, just compounded more times a year, after the 1 year, we have 55 cents more. It's not much, but every little bit matters. And because of the compounding part, it's going to make more and more difference if we keep our money invested longer. So that's kind of the idea. And then just to show you one more time, if we look at compounding monthly, we're still earning our 12%, but this time we're going to earn it every month. So if we take that 12% and divide it by 12, each month we earn 1%. And then you can see this table if you want to pause the video to look at how the table works. It's just like before. But you can see this time we earned 68 cents more. So we earned a little bit more even. And so that's the idea behind compound interest. So hopefully it makes a little more sense. Now, here's a little fun fact for you. Swiss mathematician Jacob Bernoulli, he's the one who's credited with the discovery of E. Even though it's Euler's constant, it wasn't really Leonhard Euler that discovered it. It's actually Jacob Bernoulli that's credited. So he was studying compound interest, and he noticed the more times you compound per year, the higher your return on investment. In other words, going back to this table, if we were compounding one time per year, after 1 year we only had 112. Compounding four times a year, we had 55 cents more. Compounding 12 times a year, we had 68 cents more. So the more times that you compound, the more money you make. So he noticed that. But he also noticed that as N increased, sure, your return on investment increased, but it increased at a decreasing rate. So you got more and more, but it made less and less of a difference each time. And so what he did was let's look at 1 unit of currency with an annual interest rate of 100%. And so starting with $1, 100%, how much would he have after 1 year? And he looked at compounding different numbers. So he's using this formula, the compound interest formula. And if you compound just one time a year, you're going to double your money. So you have $2. If you compound 10 times a year, you wind up with this much at the end of a year. And the more and more and more you compound, sure, the more and more you make, but notice the numbers don't grow as quickly. And take a look at they're approaching, and it's E. The numbers are approaching E. So as N was approaching infinity, A was approaching E. And so he's credited with the discovery of E. In fact, if you take a look at the formula, here's our compound interest formula. And if you're going to invest $1 at 100% interest rate after 1 year, so you let all these equal 1. So we let P equal 1, we let R equal 1, and we let T equal 1. The formula is this. And as N approaches infinity, as we're showing in the table, A is approaching E, and that is the definition of E that you probably know. And that's where it comes from, in case you were curious. Okay, fun fact over. So we have a compound interest formula like this if you're going to compound a fixed number of times each year. But if you're going to do what's called compounding continuously, which would be compounding an infinite times a year, you get this formula. And it all has to do with the definition of E. Okay, that's the end of this video.